So we're going to evaluate first, all right, and then we'll do some solving ones too. So let's try this. Let's try this problem. Again, you're going to be using any of these formulas up here are fair game. They are all in this section in your book. Okay? You do not have to memorize them. They are on your properties sheet. Anything you need from this section is on, any property you need from this section is on your properties sheet. All right. So with that said, let's try a problem. Sine of u equals 3/5. And u is between 0 and pi over 2. I need to find the exact values of sine of 2u, cosine of 2u, and tangent of 2u. What I'm going to do for today is pretty much work through problems that are similar to the ones you have on your homework assignment, because today is the last day before your test, and if you have questions, you'd have to come find time to see me, etc. So to try to alleviate some of that, we're going to work through some ones that are similar to the ones on your homework assignment and what will be like on your test. Okay? So this is one out of one of the sections on your homework. It's one of the ones like the first problem on your homework, so that you can kind of get started on a good foot, okay? Start off on a good foot. So we need to find those three function values. So the sine of 2u, we have a formula for that right here. Same for the cosine of 2u and the tangent of 2u. I'm going to write down this formula for sine of 2u. Sine of 2u is supposed to equal 2 sine u times the cosine of u. Now, to evaluate that, I need to know what the sine of u is and the cosine of u is. Well, the sine of u is 3/5. So this right here is 3/5. Okay, so I really have 2 times 3/5, but now I need to find the cosine of u. The cosine of u, if I have the sine value, can I find the cosine value? Think last chapter. Draw a triangle. Okay, so if you have a triangle, and this is your u angle, sine is supposed to be the opposite side over the hypotenuse side. So you can take opposite side is 3, hypotenuse side is 5. In the same triangle, how would you find the cosine of that angle? You're going to need the Pythagorean theorem. The cosine is the adjacent side over the hypotenuse side. You need the adjacent side length. Okay, so to find this side right here, I'm going to use the Pythagorean theorem. All right? To set that up, it's going to be 3 squared plus x squared equals 5 squared. It's like a mini problem within a problem. All right? So x squared, well, 9 plus x squared equals 25. Subtract 9 from both sides. What's 25 minus 9?
16.
Yes, and that one turns out nicely. The one on your last test did not turn out nicely. That's okay. All right, so x squared equals 16. X equals square root of 16, which is 4. Now, you should put plus and minus on that because you took the square root of both sides. However, the negative case may come into play right here. My angle is supposed to be between 0 and pi over 2. 0 and pi over 2 is right here. Should my cosine value be positive or negative in that section of the unit circle?
Positive.
Cosine should be positive. So therefore, my adjacent divided by my hypotenuse side length should come out to be a positive answer. Okay, just make your sign of your trig function appropriate for the quadrant that you're supposed to be in, and you'll be okay. So the cosine of u, if that side is 4, what's the cosine of u going to be? 4/5. Very good. Okay, so I need to take that and multiply by 4/5. I get 2 times 3/5 times 4/5. How do you multiply those? Calculator. Without a calculator, how do you multiply them?
Straight across.
Straight across. So put 2 over 1 is fine. Multiply straight across. So that's going to give me 2 times 3 times 4, which gives me 24 over 25. And that is the sine of 2u. We started with the formula for sine of 2u. And then we worked with what do we need to find this. Does that make sense? All right. How do we do the cosine of 2u? Well, let me reflect to the formulas for cosine of 2u. For cosine, there are a lot of different formulas, and some of that is because of the other properties we've already learned. Okay, like the Pythagorean identity and so forth. So there's more than one form for the cosine of a double angle. That's what this is called, the double angle formulas. All right. So cosine of 2u can either be cosine squared u minus sine squared u. It can be 2 cosine squared u minus 1, or it can be 1 minus 2 sine squared u. They will all give you the same answer. Which one do you want to use?
The last one.
Why?
I don't know.
I agree that I'd probably use the last one for this.
It was the simplest. We already know what sine.
Because you were given what sine of u is equal to. So finding what sine squared u is equal to, you just square it, right? You don't have to use the value of cosine u that you just calculated. If you made a mistake in calculating the cosine of u, i.e. you subtracted wrong, you don't want that to translate through the problem if it doesn't have to. Okay? There are times when you can't avoid using it, but if you don't have to use that, you might want to avoid it. You should get the same answer either way. It's not going to matter. Yes?
If you're using the last one, wouldn't it have to be sine squared u, and then you just double that? Because it's not the same as sine 2u.
Sine squared u is the same thing as sine of u, the quantity, squared.
Yeah. But there's a 2 in front of u, and I'm finding sine.
There's a 2 in front of the sine squared here.
Yeah.
That's not the same thing as a 2 being inside the sine value. What I'm given is the sine of an angle.
Oh, okay.
Okay, good, good. Okay. So cosine of 2u, I'm choosing to use the last formula for class. You could use any of the other 2 as long as you have enough information. All right, so 1 minus 2 sine squared u. What I just wrote down here, you may need, okay? I'm going to erase this circle because it's cramping my style right now. Okay. All right, now 1 minus 2 sine squared u. What's the sine of u equal to? 3/5. So you actually need to take 1 minus 2 times 3/5 squared. You want to square the 3/5. Okay? Be careful. You're squaring the sine function. You are not squaring the angle measure. Okay? There's a difference, is my point. So how do I square a fraction?
Square the top and the bottom.
Square the top and square the bottom. So 3/5 squared gives me 9/25. So this is actually, I'm running out of space, so I'm going to just put the simplified answer there. 1 minus 2 times 9/25. Now, how do you multiply 2 times 9/25? You know you have to multiply before you subtract. Straight across.
18/25.
That I agree with. I've seen people put 18/50ths. You don't multiply 2 times both of them. You multiply, it's 2 over 1. Okay, so this is 1 minus 18/25. How do you subtract those?
Common denominator.
Common denominator. 1 is the same thing as 25/25. 25/25 minus 8/25 is going to leave me with
7/25.
Oh, you sound so mean.
7 or 17?
So, man.
It's so weird.
What?
7 or 17? 7.
7.
Okay.
Starting.
7/25.
I think I sounded mean because Kara, was like, dude, when I said it. She thought I was wrong.
No, like I said, she wasn't looking for that answer yet.
Well,
Okay, guys.
I'm fine with getting that answer. I just
You guys
think
think
we
you're
should
looking
probably
over
talk about it a little bit to make sure everybody's up on their arithmetic
He's dating her
skills.
sister. I can't believe you just said that.
All right,
What did
Ew.
you say?
You guys act like a married couple.
so pure math. Here we go. Tangent of 2u is equal to 2 tangent of u over 1 minus tangent squared u. So now the fun begins. I don't have any other options. I have to involve tangent of u. Do I have tangent of u?
Yes.
No, but yes. What is the tangent of u equal to?
Sine of cosine.
Well,
Can do it that way. I can also look at my triangle and get 3/4. That I agree with. Okay, so the tangent of u, by the way,
3 over.
is equal to 3/4. Either sine over cosine or use the triangle and go opposite over adjacent. Okay, so the tangent of 2u is 2 tangent u over 1 minus tangent squared u. So we need the tangent value, which we have now. So this is going to equal 2 times tangent of u is 3/4. That gets divided by 1 minus 3/4 squared. Very good. I need to do some math.
Oh.
2 times 3/4 is 6/4. Yeah, but it's also 3/2. So let's write it simplified because it might make my life easier later on. 3/2 over 1 minus 9/16. Very good. 1 minus 9/16 simplifies to be what? 16/16 minus 9/16 gives me 7/16. All right, so I put 7/16 in the denominator. How do I simplify that? Flip and multiply. So I'll get
Flipping multiply.
3/2 times 16 over 7. I can cross cancel, or you can multiply first and then wait to reduce. It doesn't matter to me. Okay, just don't make any mistakes along your way and you'll be good to go. All right, so I would get 24/7. Yes?
You're so funny. This is the second comment like that today.
Now-
We're not friends.
Just reflect on your answers for a second.
What?
What do you notice about your answers?
It's like what we did a long
They have common stuff in them. They share 7s, 24s, and 25s. Wait a minute. I knew tangent was sine over cosine, right?
There's a simpler way.
There sure is. There's a simpler way than using this formula. So I could have taken a different route, and tangent of 2u is also sine of 2u over cosine of 2u. And I just found sine of 2u to be 24/25. and cosine of 2u to be 7/25. And flip and multiply that. You'll get the exact same answer of 24/25. Doesn't matter to me which way you do it. Does that make sense?
Oh my goodness.
So what part do you remember stuff?
Wait.
So are we allowed to do that?
Well, yeah, if you're asked to find all three. The problem is, there will be problems where you don't need to find these two first. You just need to use the double angle formula for tangent. In that case, you want to just stick with the formula probably.
What page is all this on? Like that?
It's all throughout the section. That's why I put them on the board. There's not one blue chart in this section of all these. There's like 4 blue charts. Okay, but they are all on your properties sheet. All right? So they're all in one spot. Also on the board. Okay? Now, let's try another problem. Let's try this one. 8
Ooh.
sine x cosine x.
I hate you all. I have measured taking that picture.
I asked you.
I just got that.
Is this another verified?
This is not a verifying one. Nope, there will be an equation in verifying. That last one wasn't a verifying one either. It was just to simplify, evaluate. Okay, verifying ones in this section, we're gonna wait for a minute till you get used to using these formulas, okay? The instructions for this problem are as follows. Use a double angle formula to rewrite the expression. How could I use a double angle formula, which is one of these that have a doubled angle in them? Go.
You would just square root them, right? Because if you only have the sine one, then it would be just a half of those equations.
You can't do that. You can't do that, but that's a common misconception.
Would you use the top
Okay?
one?
You cannot just split the angle in half and split the sine function in half. That's not true. Okay? However, the top one kind of looks like that over there as a result. Okay? 2 sine u cosine u is equal to sine of 2u. So I can rewrite 8 sine of x cosine of x. That's the same thing as 4 times 2 sine x cosine x. The advantage to writing it that way is so that you see blatantly that this is the exact same thing as the result of the double angle formula. Does that make sense? Like this right here looks exactly like what sine of 2u is equal to, except my x's are u's.
So do we just do the
Okay.
whole problem like that?
So 4 times sine of 2x. Now,
Oh, yeah.
Wait,
question.
Yeah.
Get lost? Okay.
Yeah.
Why'd you take the
Why'd you take the cosine out? Because this whole thing together is equal to sine of 2u. You have a sine of 2u is equal to 2 sine u
But u is really
cosine u.
x.
Say that again?
But u is really x.
Well, yeah, I can change that to x's.
Ah,
Doesn't matter, it's just
No.
variable.
Yeah, it's just an angle. So this right here is exactly what I now have here. Do you see that? If I had 8 sine x cosine x, that's the same thing as 4 times 2 sine x cosine x. So I really have 4 sine 2x's. Does that make sense?
Yeah.
Okay. Can you multiply the 4 and the 2 and get sine of 8x?
No.
Thank you. A lot of people would.
Would
Okay? This set of parentheses is not multiplication. You cannot flip the order around. All right? It's composition. Sine of 2x is one thing. It's not separable. All right? So that's your final answer. You can write it as 4 sine of 2x and be done. It's either way. Doesn't matter. Same thing.
So that's not the answer?
You did what was asked. You rewrote it with the double angle formula.
So what?
Wait, what were the instructions for that one? It was use a double angle formula.
Use a double angle formula to rewrite the expression. So you're looking for one of these things over here, probably the result, so the equal sign over here,
That's what I'm using.
to turn it into a double angle formula. Okay? Now, let's try another one. All right, here we go. Let's do this. I'll write the problem up there first. Sine squared of x over 2. Sine squared of x over 2. The instructions are as follows. Rewrite the expression in terms of the first power of cosine. It says use a graphing utility to verify your result, but most of you don't have a graphing calculator, so we'll just stop there. Okay? So rewrite the expression in terms of the first power of cosine. So I'm trying to turn this thing into something with cosine of a quantity. How can I get there? Well, let's see. Let's use a property. So I have several properties. Maybe one that transfers sine squared of something into something with a cosine. Maybe that one will really help me actually. Okay?
Yeah.
Maybe the one that has sine squared in it is going to be useful here. Another one that some people, if they were starting this problem from scratch, might look at and say, maybe I need that, is one where you have an angle divided by 2 inside of your trig function of sine. That one will also work. Okay, so you still have a cosine to the first power, but you have a square root around it. Oh, but that one's squared. What do you think is going to happen? They'll probably cancel. Okay, so either one will probably work. It's just a matter that this one's probably going to be easier. The squared trig function is going to be easier. So sine squared of u is equal to 1 minus cosine of 2u over 2. Let me write that down over here so you have it. Sine squared u is 1 minus cosine of 2u all over 2. You have to copy formulas exactly, so make sure that this is a minus here. Okay? Apply that to this problem. Let's see how you are at it. Okay, so what is sine squared of x over 2 going to be?
1 minus.
This is already equal to sine squared. So the squared, I don't need to deal with the squared part. Does that make sense? Wyatt, go.
1 minus the cosine 2, then like the parentheses, x over 2,
Okay, good.
and then over 2.
Very good. The angle u in this problem is x over 2. So you need to replace u in the formula with x over 2. This 2 in my problem, in my formula that gets multiplied, stays there. Okay, it doesn't get replaced. You only replace the actual variable of u. All right?
I think so.
Does that help at all?
It's right there.
No? You sure?
Can you explain it one more time?
Sure. So the angle in your sine squared function is x over 2. So when I have sine squared of u, my angle is now x over 2. So I'm going to replace all of the u's in my formula over here with x over 2's. Does that make sense? Okay, it's like if I were to put this overlaying on that, my u and my x over 2 would be in the same spot. So my x over 2 needs to go in the same spot of all of my u's over there. You don't drop that 2 though. You know? Okay? All right, so, but now you can multiply the 2 and the x over 2. What is 2 times x over 2?
X.
X. So this is actually 1 minus cosine of x all over 2. You've accomplished the question asked. You said you've written the expression in terms of the first power of cosine.
Why do you have the arrow pointing down?
Because that's where I was trying to end up. The instructions said rewrite the problem as the first power of cosine. So I was trying to keep my end result in mind. I wanted something with cosine to the first. Does that make sense? And my end result has cosine to the first in it and nothing else. All right? Okay,
That's the answer?
that's the answer.
Yeah, she's.
Wait,
I get it.
oh, okay, never mind. I was trying to figure it out.
All right, let's take a look at this one.
It's like, oh,
Yeah,
this is on this bottom one, kind of like giving them.
Sure.
Can you tell me the directions for the last one more time?
yeah. Rewrite the expression in terms of the first power of cosine.
No, not this.
I think it helps when you tell us the directions.
Good. Remind me. We'll keep doing it.
Will the directions be on our test or not? Like what? Like you put no.
She's just gonna give us that.
That's not right. But like the. Like the
I
end result.
try to use the same words.
So it's gonna be worded pretty much the same.
I try to use the same
So
words.
you're gonna put like we have that exact problem. Like you're gonna put like you want to end up with cosine or not?
I'll write it just like it's written and like I just
In
said.
terms of the first power of cosine.
Rewrite it so that it's in the first power of cosine or something.
Okay.
I probably would not give you that exact type of problem. I would probably say, you're going to use these in solve, so I would probably say solve. And then you need to be able to do this in order to solve. Like this is something that's a tool. This is an important thing, guys. Hey, rewriting something in terms of the first power of a trig function is an important skill for being able to solve equations as well as verify equations. So the likelihood of you having these types of evaluate problems, because I have to pick and choose what goes on a 45-minute test, probably not going to happen. I can test you over this at the same time that I can test you over, do you know how to solve? In one problem. See what I'm saying?
The first one didn't.
Okay.
She's gonna give you that, so you can keep it over here.
Hey, Echo.
Yes.
So is that not the only answer for that, or like?
If you use this formula, you're going to have to simplify a little bit.
But can we use like any formula that has cosine in it? What?
Any formula that had sine squared and cosine in it.
Okay.
Just like that one.
That one doesn't. Okay, it has like.
That one had, this one right here has a half angle, which you also had in the problem. It was sine squared of x over 2. So the question of do I use the half angle or the squared function, doesn't matter, is the answer to that question. You can use either one. Okay?
Does the answer change depending on what?
Not if you simplify it, should not change.
What?
Okay.
What's the nearest?
All right. How about this, guys? Here's the directions. Ready?
Okay.
Use the figure to find the exact value of each trigonometric function.
So
I
we
think
have
we've
to
seen
find,
something like
that.
Or,
I haven't given you the functions yet.
Pythagorean Theorem first.
So A is cosine of theta over 2.
Yep.
Ah, that's how this ties to this section. So I've seen problems like this before.
Can you repeat the directions? Sorry.
Yeah. Are we all right? Okay. So the directions again are find the exact, use the figure to find the exact value of each trigonometric function. Now, Ricky said a minute ago, use the Pythagorean theorem.
Yes, I did.
Find that third side. You probably need to find that third side because cosine is adjacent over hypotenuse. We don't have the hypotenuse. That's probably an issue. So let's find that first. 15 squared plus 8 squared equals my hypotenuse squared. 15 squared is 225.
Yeah.
Okay, so 225 plus 64 is equal to,
289.
and that
17.
is 17 squared.
Give me some.
You don't need plus or minus because this is a side length, and the hypotenuse of a triangle is always positive, even where, no matter where you are on your unit circle. Okay? So, now, here's the problem. So that's 17. I need the cosine of theta over 2. So you're telling me I have to get
You
the,
have to find theta.
I have to find theta?
No.
You could find theta, but that's not, you'd need a calculator to do that. What if I don't need a calculator for this problem?
You need a calculator.
You don't.
15 over 7 over 2.
Huh?
You can use calculator.
Is it? Oh, wait, never mind.
You cannot just divide the cosine value in half. The cosine of half the angle does not equal the half of the cosine, okay?
Wait.
So,
15 over 17 divided by 17.
can't do
Can you
that.
use those things?
Go.
Can't you use one of those things and then put the...
Ladies and gentlemen, she has a good idea.
What?
Can't you use these things?
You gotta use
Yeah.
that one.
Cosine u over 2.
The second one, yes, that one.
That one.
Source we promoted that.
Okay, so I know, let me write that down. The cosine of u over 2 is equal to plus and minus the square root of 1 plus cosine of u over, all over 2. Now I want to point something out to you. In this formula, you have u over 2 as an angle, and you have u in the formula result.
I'm in the formula? Oh, you, okay, never mind. I didn't know. I wasn't-
Okay, so cosine of theta over 2 is equal to plus and minus the square root of 1 plus the cosine of what?
Theta over 2.
But u is over 2 in my formula,
Can you use Stanford?
Oh, theta over.
so it's just theta.
Yeah.
And your u value is theta. So 1 plus the
Theta.
cosine of theta all over 2. And you might be going, that didn't do me a single bit of good. Now I'm just, it's a more complicated formula to evaluate. Except that you can find the cosine of theta. You couldn't find the cosine of theta over 2 from the triangle. You can find the cosine of theta with the triangle. What's the cosine of theta? Adjacent over hypotenuse, so 15 seventeenths. So the cosine of theta is 15 seventeenths. You're using that SOHCAHTOA cosine adjacent over hypotenuse ratio. So plus and minus the square root of 1 plus 15/17 all over 2.
Now you.
Before we go on to the algebra simplifying things for this problem, do you understand where that comes from?
Yep.
We good?
Sure.
Okay. So how do I add the 1 and the 15/17?
1 over 1 and then find the
No,
denominator.
17 over 17.
Which is 17/17. What is 17/17 plus 15/17?
1 and 15/17.
Let's keep it in improper fraction.
That's a good one.
32/17. Okay, so plus and minus the square root of 32/17, and that's all over 2. The all over 2 is underneath your square root. I should point that out. Flip and multiply, still under the square root.
So 1/2 times 32.
No.
Yeah.
I was still on the first step.
Cancel out 16,
You
16 over
can
17.
cross cancel
16 over 17.
16. So that turns into 16 and you get a 1 on the bottom. So I really have plus and minus the square root of 16/17. And because of time, we're going to leave it like that. You could square root the top and square root the bottom and rationalize the denominator.
That's fine.
We got our calculators.
No, you don't need a calculator.
I don't know what the square root is.
That's right.
Okay,
So you
it's
leave it.
I don't know.
Set off my